Okay, so in this slide, we are going to talk about different ways that scientists depict molecules when they need to talk about a specific substance. Sometimes we need to write it down. Instead of writing the whole name out, we want to write out the molecule itself and show something about its structure. So here we have something that hopefully everybody is familiar with. This is water, H2O, and we've got two different ways here of showing of depicting a water molecule. This one here, this is what we would call our molecular formula. And just like on the previous video, we said that the molecular formula shows you how many and of which kinds of atoms are involved in this molecule. So we have 2 hydrogen atoms and 1 oxygen atom. And if there's 1 oxygen atom, we don't put the 1 there. We just assume that you know there's 1. So in this molecular formula of water, this formula is simply telling us that a molecule of water contains 2 hydrogen atoms and 1 oxygen atom. It's like a recipe. All right, now on the right side of this slide, we have this, and this is what we would call the structural formula for water. And it's giving us a bit more information. It's telling us how those atoms of hydrogen and oxygen are laid out and joined together. And so you can see here there's a covalent bond shown by a solid line linking this hydrogen atom to this oxygen atom. And we know that a covalent bond is a shared pair of electrons. So what's really going on between these two atoms is a shared pair of electrons. So one of the electrons is coming from the hydrogen, that's the red electron, and then one of the electrons is coming from the other atom, so that might be the black one, and so they're sharing that pair of electrons to join themselves together. So we have a molecular formula on the left, just a recipe, and a structural formula on the right. And that's where you see it drawn out with the covalent bonds and how everything is joined together and what's joined to what. Now with H2O, it's pretty simple. There's 2 H's and an O. I guess it could be like this. If you didn't know anything else about chemistry, you could have an H and another H and an O. Now, if you know something about chemistry, that's completely wrong. There's no way that that can happen, and we'll dig into that in a couple more videos. But this diagram here does potentially have 2 H's, 1, 2, and 1 O. So it's meeting the requirements that the recipe is telling us, but it's not correct. And we'll get into that later. But you can see how you can get different information from a molecular formula and a structural formula. That's all very good, but we can get to some more complicated molecules. So here is another structural formula over here. This is a molecule that we're going to get to know pretty well in this class. This is glucose. It's a sugar, otherwise known as blood sugar. This is the sugar that is dissolves in your bloodstream and is transported around your body and used for energy. So in a single molecule of glucose, you need 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. That's the recipe. You need those different atoms to create a single molecule of glucose. But you can see here, it's a much bigger, more complicated recipe. So potentially there is more than one way of linking together these numbers and types of atoms. And so to really have more information about the actual shape of the molecule and the pattern of how they're all joined together, we need a structural formula. So here's the structural formula of glucose. Now, yeah, it's starting to get a little more complicated. It looks a little bit more sciencey here. So in this class, there is no expectation for you to be able to take something like this and draw that from it. I mean, that's a level of skill that you'll learn in organic chemistry classes, and we're not going to go there in Bio 181. So don't start panicking that there's no way that you would ever be able to figure out this whole diagram from the recipe. You're not going to have to do that. But one thing I do want you to be able to do is to understand what this structural formula is kind of telling you. So every single one of these solid lines represents, so there's a solid line there, there's a solid line there. Every single one of those solid lines represents a covalent bond that's joining one atom to another. So those two atoms are sharing a pair of electrons. So we have this oxygen here and this carbon here. They're sharing a pair of electrons right here, and that connects the two together. And we can depict it with that straight line or that covalent bond. So if you look more closely at this molecule, this structural formula, you can see that there are some lines on here that are thicker and some that are thinner and some that are tapered. What is going on with that? This is kind of a somewhat confusing thing. In this diagram, this single solid black line between these two carbons and this single solid black line between these two carbons, they're basically showing the same thing. It's a single line, it's between two atoms, it's connected together, so these are two different covalent bonds. They're covalent bonds, but there's nothing different about them. They are the same as each other. You might ask, well, why is one thin and why is one thick, or why is one tapered and why is one not? What's going on here is that the person that made this diagram is trying to give it some sort of three-dimensionality. It's trying to make you think that the fat line is closer to you and the thin lines are further away from you, and to try and make this look like a three-dimensional shape where part of it is sort of coming out of the screen towards you and is closer to you. I don't think it really works. It's not a very good visual to me. I think it's just confusing. But either way, all these lines, whether they're thin or thick or tapered, they're all just the same. They're all representing single covalent bonds. All right, and you don't have to do thick lines and thin lines. You just can do sticks. It's fine when you draw something like this. Now, the other thing that is important to understand is that, so here, right, there's an O and an H, and there's no line between them, right? It looks like that H is just either, it's not attached to that O, or it's just up against it, or for whatever reason, that there's no line there. Now, this is a sort of shorthand that scientists use when they're communicating with each other, and they just assume that because otherwise, why would you be looking at a diagram like this if you weren't a scientist, that that this OH is really O with a covalent bond to an H. They've just missed that line out. They're just not showing it. It is there. It's just, there's thousands of different molecules that have a part where an O is stuck to an H. And so to try and save space and to try and make this look a little bit less busy and complicated, they've shorthanded those lines and missed them out. So how would you know they're there? Well, you wouldn't necessarily unless someone's told you that they're there and they're just being skipped and it's just a convention that we all agree on. So I'm telling you now, maybe for the first time, maybe you've heard this before, but this OH is really O line H. And this OH is really O line H. All these cases. And up here at the top here, you've got a whole bunch of things like joined together, well, a whole bunch of things one after the other like this with no lines. This is something else that this sequence of atoms happens quite often in organic molecules. And what's really going on here is there's a C, which is that one there. It says two H's, and there's actually an H up here and an H over here. And then there's an OH, so there's an O here and an H here. Now, you can see I've drawn that out, and it's starting to look really big, messy, and confusing. And that's the very reason why we avoid drawing everything out if we can shorthand some of it. So let me take all this out, and you can see it looks a little neater with all my scribbles taken out. And now, you know that when you see an OH, it's actually an O line H, but we've not put the line between them. And then the CH2OH, there's a bunch of stuff going on here. Again, at this point in this class, I'm not expecting you to be able to draw this out in its entirety. I just want you to recognize that these atoms are all connected to one another by covalent bonds. We're just not depicting them in this diagram. So I hope that helps you to start to be able to decipher some of these more complicated molecular structures. Once again, don't panic when you see something like this. I know it looks big and sciencey and complicated. If you take a deep breath and kind of dig into it, you can decode it. You can, step by step, try and understand what they're trying to show you, what's connected to what, how the thing is all stuck together. It's not as scary as it looks.